This question is based on the concept of hash table and asked in LoS. Also, it is marked as easy, so it's a good beginner-friendly problem. Not that easy, but yeah, you can get started with this. Let's have a look at the problem statement. You are given an integer array nums and an integer k. These two values are given to us, and after that they are saying that an integer h is called valid if all the values in the array that are strictly greater than h are identical. They are saying that any integer h will be called valid if all the values in the given array which are strictly greater than h are same. What they are trying to say is we should only have one type of value which is greater than h. There is only one value which is greater than h, and that can be multiple times. For example, nums 10, 8, 10, 8. We have a valid integer h equal to 9. Okay, if we choose 9, there is only one element which is greater than 9, that is 10. It is the same thing, that all the elements which are strictly greater than h is identical, like are identical or is having the same magnitude. So okay, this is our condition, something given to us, and now this is our operation. You are allowed to perform this operation on the nums. First step in the operation is select an integer h that is valid for the current values in nums, right? So whatever nums array is given to us, we have to choose h according to our values. It means when we are choosing h, we should make sure that okay, there is only one type of item greater than h, right? Because that is the similar thing of saying this line, that all the elements greater than h are identical. So this is the first step. Choose a value of h, and then for every index I where nums I greater than h, set nums I to h. Okay, so and then after we have picked the h, whatever is the value which is greater than h, because of greater than h value is only one type in this case. Let's say in the given example 10, 8, 10, 8, the h was 9, and what is the value which is greater than h? That was only 10. So set all the occurrences of 10 equal to h. So this is the second operation. And now what we have to return? Return the minimum number of operations required to make every element in the nums equal to k. If it is not possible, return -1. The problem statement is a bit confusing, but let me explain it to you with the help of an example. See, first of all, what is given to us? We are given an integer array nums and an integer k. And what operation we have to perform? First of all, we have to choose h for corresponding to this given nums. And what is this h? We have to pick any integer. And what is the valid value of h? How do we choose the h? See, we have to keep in mind that there is only one type of element which is greater than h. Okay. Or in other terms, we can say all the values which are greater than h should be identical. The same thing. So we are just skipping it. We have to choose a value which are greater than. So we have to choose a value which is greater than h. So here in this case, what is the biggest value? 5. Because we will be choosing in such a way that there is only one type of value greater than h. So h should be less than 5, and it should be greater than 4, because 4 is the second biggest value, right? If I choose 4 as my h, right? Why 4? I'm just choosing a value which is slightly lesser than the biggest element. Biggest element is 5 here. Smaller than the biggest element, there are values like 4 or less than that. But 4 is the second smallest element. So we have to choose 4 in this case. Choose 4, and now let's try to validate if value of h is perfectly valid or not. There is only all the elements which are greater than 4 are identical. See, all the elements greater than 4 are these 5, 5, 5. These are identical. Yeah. First step is done. Second step is convert all of these values to h. So 5 will become 4, 5 will become 4, 5 will become 4. And this is my first operation. In the first operation, I have removed the biggest element, in short. Now the state is 4, 2, 4, 4, 4. Now in this case, we have to choose a value of h. such that values greater than h are identical. If I choose 2, yes, I can choose 2 as a value of h. If I choose 3, yes, I can choose 3 as a value of h. Let's say I am picking 3. Why 3? Because there is only one element which is greater than 3, that is 4, and only 4 is available. So 3 is a valid h, and first step is done, choosing a valid h. Second step is converting all of these values which are greater than h to h. So converting 4 to 3, 4 to 3, 4 to 3, 4 to 3. Okay, now the state is 3, 2, 3, 3, 3, right? But if we just have a look on the problem statement, return the minimum number of operation. We have to choose the minimum number of operations to make every element equal to k. So in this case, we might require one more operation. So we are not going to choose 3. Instead, if we choose 2 as our value of h, then these are the values greater than 4, and these will be converted to 2. And after that, every value in the array is converted to k. K was given 2 in the starting. So this is something we can do. First of all, we have to pick the second largest element. Why second largest? Because there should be only one element which is greater than that, and that one element can come multiple times. So if we are only concerned about 5 only one time, so just capture how many times 5 is coming, and then second element is 4. 4 is coming one time, 2 is coming one time. So what we can do here is, let's say somehow we have this set ready with us. Here I'm going to pick the second largest, and if the second largest I have picked as 4, I'm done with this in one operation. And then I will just pick the second largest, and I will be done with this one more operation. So after 2 operations, I will be able to get the answer. And why I'm done with this, like, let me show you again. 5, 3, 4, 1, 2 is coming one time. If I am choosing 4, there is only one element which is greater than 4, and I will be choosing all the instances and converting that to 4. It means all of that value will be converted into 4. So 5 is gone, 4 is coming 4 times now. Now the same thing I can apply again, choosing 2 and converting all 4 to 2. So it will be 2 is coming 5 times, and now after 2 operation we are done, right? See, there is one thing to consider, because there might be so many corner cases in this problem. One thing is that every time we are reducing the value, if the nums I is greater than 4, it will be equal to the 4. It means that we are reducing the value of num. There is no way to increase a value, but our ultimate goal is to convert every value equal to k. If let's say the array is something like this, 2, 1, 2, and the value of k is 2. See, in this case, if I just capture the map as well, 1 is coming one time. If I choose 1, I can convert all of these 2 to 1. But we have to make every single element of the array equal to k, right? But I'm getting 1. So in this case, I don't think there is any possible solution, because there is no way to increase the value of any element. We can only reduce the value. In that case, the answer is not possible. So we got the idea. If any element is less than k, then directly return -1. So this is one condition we have to like put as our corner case. If any element is less than k, just return -1. Otherwise, what we have to do is, for every bigger element, let's say for the above example, 5, 3, 4, 1, 2, 1. For every bigger element which is bigger than k, 5 is greater than k, there will be scenario that we will be able to get rid of that element. We got rid of the 5, we got rid of 4, and then 2 we don't have to do anything, like, because 2 is equal to k. So for every element which is greater than 2, I am doing something. I will be able to perform the operation, and it means how many times any value is greater than 2, like how many different elements which are greater than 2. For every possibility, I am going to apply operation one time. Okay. So in this case, we apply two operations. In this example, we are not able to perform the operation because this value is less than k, and in this case, there is no possibility to get the answer. If I give you one more example, let's say 9, 7, 6, 3, and the value of k is 2. In this case, I am going to pick 7 first. Why 7? Because after 7 there is only one element. If I just get one more 9, it will be 2. If I pick 7, there will be one element which is greater than 7. How many times it comes, it doesn't matter. And we will be able to perform and convert that 9 to 7 in one operation. Okay. After one operation, we got rid of the maximum element. After one more operation, we got rid of the second maximum element. After one more operation, we got rid of the third maximum element. After one more operation, we can get rid of 3 and convert it to 2. Because for 3, if every element in this array is converted to 3, I can choose h value as 2. I can choose h value as 2 and convert every single element to h. So from this example, we are getting an idea for every element I, which is greater than k, we will be utilizing one operation, and this is for all the occurrences of I. All the occurrences of I, it means all the unique values. So what are the unique values from this array? 9, 7, 6, 3. For all the unique values, if I just use a set to capture the unique element, so whatever value is in the set which are greater than k are adding one operation in our effort. And if at any moment I am encountering a value which is less than k, then -1. Right? So this is the idea that we got from by just running the couple of dry runs. Okay, now let's directly try to see the approach. Let me take the same example, 5, 2, 5, 4, 5. Now this is our example, and we will just try to build our final approach. Our final approach is something. First of all, we need to know what are all the unique elements in this. To capture the unique element, we can keep on maintaining the set. I will keep on maintaining the set. If in the set I will just add items, I will add 5. Okay. If I add 5, I will see whether that element is greater than k or not. If it is greater than k, it will be contributing to one operation. If any element is equal to k, it means ultimately we have to convert all the elements to k, and the k, for k we don't require any operation. So for k I can just directly skip it. If it is greater than k, I will do something. If it is less than k, then there is directly -1. No possible solution for this problem. So what I can do is I can directly pick element and add it to the set. If it is added successfully, for all items in array, I will just add it in the set. Added in set, it means it was the first time we are adding this element. Then I will check the value. If the value is greater than k, my operation count is incremented. If value is less than k, directly return -1. No possible solution. If it is equal to k, we don't have to do anything. That's all we have to do. And this answer ++ will be my answer. Return answer. Okay. So what approach I am following is that I am adding every single element into the set. Let me create a set. And first of all, I am adding 5. If I am adding 5, okay, one contribution to the operation. For 2, no, nothing. For 5 is already added. It is not added successfully. So if it is added successfully, then I will contribute it to the answer. 5 is already there, just skip it. 4 is not there, so 4 is added to the set, and answer count is incremented. 5 is already there, so 2 will become my answer. And what is the time and space complexity? I iterated over this array. But if we have a look on the constraints, the nums.length will go till 100. So what can be the maximum size of this array? Maximum size of this array can be 100. And what is the maximum size of this hash set? That can also be 100. So in this case, time complexity is order of n for n till 100. Otherwise, if we consider that 100 is a constant one, then it's a constant time, constant space. But otherwise, you can have a look and you can decide accordingly what do you want to call. Till 100, it is linear time, linear space. Okay. Now let's code this approach. So here we have come to the conclusion that if any element is greater than k, that is contributing 1 to the answer. Otherwise, if it is equal to k, there is of no use processing that. That is not going to contribute to the answer. But in some possibility, if any element is there which is less than k, then there is no possible solution. And the value of any item will go from 1 to 100. So what we have to take is, we just have to take a set. Hash set we are going to use. Set of integer set is equal to new hash set. And then for at least we have to visit every single element. So int I equal to 0, I less than nums dot length I plus plus. Now from the elements given to us, we have to check only two possibilities: if any item is greater than k or it is less than k. If any value is less than k, in that case directly return -1. We don't have any answer. What if it is greater than k? If nums of I is greater than k, in this case this is going to be contributing one time in our answer, and it will be added to the set dot add nums of I. If it is already added, it won't make any difference to the set. Ultimately, whatever is the size of the set, that we can directly return. Instead, we don't have to check for the answer, like check for the times when it is added in the set. We can directly return the size of the set dot size. So for every element in the set, we have element greater than k. So for every greater than k element, we need to do one operation. Now let's test our sample test cases. It is submitted successfully. I hope you understood the approach, and the problem statement is a bit tricky, but we have to analyze on the example. So just do the dry run on an example, or maybe just process the example to get the approach. Thank you guys. Bye bye.